So we're here to talk through this challenging TomTom puzzle by Freddie. It has a really beautiful mirror image theme. It has a much more challenging solve, and so some people may have been frustrated by this puzzle, but we wanted to talk through some of the ways to get through grids like this. And it really starts with something we don't do as much of, but when we have such a limited number of types of cages, it's helpful to remind ourselves about how groups like this can be filled in. So I'm actually going to start the puzzle by just writing all the options for these groups. A 2 cell 2 can be 1 times 2, or 2 divided by 1, however you want to think about it. It can be 3 minus 1. Nothing else with 1 as the smallest digit. It can be 4 subtracted from 2. It can be 5 subtracting 3. It can be 6 dividing 3, or it can be 6 subtracting 4. Again, always the smallest digit on the left here. A lot of options for the 2. There are less options for the 5. Again, the ones that use a 1 as the smallest digit are 1, 4, 1, 5, 1, 6, where this is addition, multiplication, division, or subtraction. If a 2 is used, a 3 is in the cage. There's no other option, 2, 4, 2, 5, 2, 6, and nothing higher. These are actually the only options. And one thing to see is that a 5 cage always has a 1 or 2, a fairly low digit in it. Because of that, one thing we can actually say off the bat, it doesn't get us too far in those puzzles. Like, 1, 2 is not an option up here because it eliminates everything in the set. And it's more as we get into the solve, we're going to see how this 1, 2 observation is important. But it's really going to come from looking at these bent groups. And so the bent groups may seem a little harder to map, but we'll think about them now. The 5 is a sum or a product. The only product is going to be, and I'll write this kind of what would be where we're needed, maybe a group like this, where the center is sometimes this number, at least like when a thing is repeated. I'm trying to get the sense that the 2 1s are in these cages, but maybe that's not too helpful. Anyways, a product can be 1, 5, 1. There are different ways it can be a sum. If it's a sum, let's sort of take the largest possible digit. If it were a 3, there could be a 1 and a 1 to complete it. And again, this would need to have the 1s on the outside and the 3 in the center. And if the largest digit in the sum were a 2, there's actually an option which is 2, 1, and 2. And that is very much all the options here. And a thing to note is that all of these options include the digit 1. And so I'll mark it just here, but it's also true here. One of these cells is a 1, one of these cells is a 1. It's not forced that both of these are 1s, but as we actually think of the interaction to these cages to the left and even to the cages above, these matter. For instance, if 1, 5, 1 is put here, then this group with a 5 up above has to be 2, 3, because all the options to have a 1 are now removed. And so this observation of needing a low digit here and that these groups are using up a fair number of the low digits is going to be important. There are more options over here for the 2. The smallest possible option is a product, which is 1 with 2 with 1. There are a few options which are subtraction, and one of those is let's go from the smallest, look at the largest digit. If there is a 4, it could subtract with 1 and 1. It could be a 5, and that would need to subtract 1 and 2. It can be a 6, and that will subtract 1 and 3, or 2 and 2. And there's also an option which is a division. There is 1, 4, 2 as a type of division. And there's also 6 where it'd be 1 and 3, but that's already in the list. So more options over here again than over here. These 2s are more permissive, but a few things we can already do straight off the bat. Knowing that a 1 has to be somewhere in this cage. These options that use 2 1s to fill in both of these spaces are not possible. That's hopefully an obvious enough thing to see. Next kind of thing to observe is that when, I guess there's sort of 2 ways to think about it. If I'll start this way. We'll start by marking that these 2 cells are 1 and 2 and that they're actually the same. I think that's an interesting but important observation. And the next thing we really want to think about is there a way that, remembering that a 5 always has a 1 or 2 in it, is there any way this cell is a 1 or 2? And in practice there's not, but what we have to do is think about the interactions of these groups and where it allows a 2 over on this side. if we have either of these top options, 1, 5 or 1, 3, 1, the only option left is 2, 6, 2. It's the only option that doesn't have a 1 in it, and so a 2 would be forced in this group. The other option that's in the space is 2, 1, 2, which also puts a 2 in this row, and so you can say that this is a group larger than 1 or 2. This is a 1, 2. The next thing to recognize is actually a more powerful statement is now that these two digits are the same, is it the case that this digit is different or the same where it's also a 1, 2 digit? And recall that this group up here also needs to have a 1 or 2 somewhere in it. If these are both 1s, this digit is a 2, which means the remaining one is a 1. If these are both 2s, the remaining digit up here is 1, which means this is a 2. And so these three digits on this diagonal are all identical. And they can all three be 1 or they can all three be 2. And what we now have to work through is how does that leave behind anything for the rest of the puzzle to work out. We're going to need to remove some more of these options, but we'll eventually distill down to a working one. That all of these groups have 2 1s or 2 2s means that this option 1 4 2 and this option 1 5 2 that have either a 1 or a 2 have no place to go. If these are both 2s, that's dead. If these are both 1s, that's dead. 1 6 3 can fit in, but it's actually going to cause a bit of a problem. If 1 6 3 is used, the remaining digit is 2 1 3, and recognize that what you're going to have is a 1 up here and a 1 in the cell. So I can mark something like this, I guess. We're actually going to know right now that a 6 is in one of these cells. With the 2 1 2 option that puts 1 6 3 up here, a 3 is being used and all of these digits are 2s. And in the case where all these digits are 2s, this cell wants to be a 3. And so 2 1 2 places a 3 in this cell. 1 2 3 all in this space, and that actually blocks all of these considerations. So it's the hardest one to eliminate, I think, as you get through all these eliminations from 6 options here and 3 options here, but 2 1 2 isn't possible. 2 1 2, once we actually see that all of these are 2s, makes 1 2 3 sit in this space, and that eliminates everything over here. So long way of saying, got a 1, got a 1, got a 1. We don't know which these are of 3 or 5, but we actually now know for sure we have a 2, and a 2, and a 6. The remaining digits in the space are 3, 4, 5. The remaining digits up here are 2 and 3. This 1, 2, 3 eliminates everything but 4 and 6, which actually comes in this way. Leaves behind a 5, which leaves behind a 3, which forces this 5, which gives this 4. 5 needs to have a 1 or 2 in it. The digits that use 3 are the 2s, so this is 1 with 4 or 6, 4 or 6. There's a 2 somewhere down here. Actually, I'm missing the fact that 1 is in this cell, and this is a 4, 6. We actually have placed 4 1s, so I'll place the last ones in as clues here. I think this 2 is going to be fairly constrained. It's not anything with a 1, it's not anything with a 4, so this is a 3 with a 5 or 6. And what that means is the 2 in this 4th column is down at the bottom, and there's a 2 over here. Now we talked about how 1 and 2 have to be both shared in a 5 cage, but they are never both in a 5 cage, and so we actually know that the 1s are kitty corner, but it actually turns out this 1 and 2 are kitty corner, and this 2 and this 2 are kitty corner, so there's going to be like a 1 1 2 2 or 1 1 2 2. Now they're pretty big patterns, so maybe hard to get it all in your head, but the thing to be thinking about is how, as that fills in, does it leave the rest of the row possible to be completed with other digits. A really bad situation we saw before is when 1, 2, and 3 were filling up some space and getting the rest of the group to fill in. And if this is indeed 1, 1, 2, 2, there's a 3 in the cell, so we have 1, 3, 2 here. at least behind a 4, 6, but there's no place in this row ever for a 5. The 5's already in this column, it can't come over to here. And so we can't fill this in with 1, 2, 3 on the left side. We need to do the other option, which is 1 down below, 1 up, 2 down, 2 up. The only remaining option in the cell is a 4. And we have some options over here still, but we've got the start of what we need in the grid, where this is a 4, makes this be a 6, makes this be a 4. The 5's already in this column, so we have 3, 5, 3. 3 comes up here, 3, 2, and 2. 3 comes over, got 5, 6. There's a group there. This is actually a 4, 6. Pair, this is a 5, 6. 5, 6. That actually eliminates the 6 option here. So 4, 6, 5, 6, 5, 6, another 5, 3, and 4, and we're all the way through to the end. I hope at least this TomTom has now stood up to its 4.5-star rating. It might even have been a 5-star, but I think depending on how you test options in these cages, you can land on the solution quite fast. And so it does take a little more deliberate status to find the full logical path, and we showed you the way I was able to get through to that to prove it had a unique solution. It came from a few interesting deductions, kind of the limited set of options for this triple that always have a 1 or 2 on the outsides, and then the recognition that 5s always have a 1 or 2 within that cage. Like, it's not a common use of the deduction, but it forces a pressure with this 5 and with these 2 clues where these 3 numbers must be the same. That being the same, we get to where we can't spend all the low digits here because of the use on the left, and so you get 6, 2, 2 identified, get this space identified, slowly get the top. We still have some challenge on the bottom, but it again is using aspects of the 1, 2 on this 5 to have an alternating pattern of these clues. Get that filled in. So it's a big challenge. If you got through it yourself, congratulations. If you needed some help, no worries. Hopefully learn something about how to solve this puzzle and have some new tricks for TomTom in the future. We'll see you again soon.